Hello, this is Dr. Henry, and today we're going to be looking at how to balance a redox equation. So the first thing we want to do when we look at this is we need to figure out what's being oxidized and what is being reduced. So we have chlorine here and chlorine here. We have nitrogen here and nitrogen here. So that's probably a pretty good idea that even without looking at the oxidation numbers, that these will be paired up and these will be paired up, right? So if we look at this, oxygen here is -2, so that means nitrogen is +2. Over here, oxygen is -2. There's 3 of them, so that's -6 total, but the whole thing is equal to -1. You've got 1 nitrogen, so the nitrogen must be +5 in order for that to equal -1. So if we look at this, nitrogen is going from +2 to +3, so nitrogen is being oxidized. So that's one of our half reactions. So we have NO is going to NO3 negative, or nitrate. So nitrogen monoxide is going to nitrate. All right, here we have hydrogen is +1, oxygen is -2, so chlorine has to be +1. Over here, chlorine as the element by itself, even though it's a diatomic molecule, we consider it an element, it has a oxidation number of 0. So chlorine is being reduced. So it is our other half reaction, and that half reaction is going to be HOCl goes to Cl2. And we'll balance that in a second. So let's do this one first. So the first thing we need to do is we need to make sure that what's being oxidized has equal numbers. So we have 1 nitrogen, 1 nitrogen. And then this nitrogen goes from +2 to +5. So we need to balance the oxidation numbers. And in order to do that, we're going to add electrons. So electrons are negative. So this is going to bring this side down. We need to bring our reactant side down to +2. So we're going to add 3 electrons because 5 plus 3 electrons gives us a +2. That'll be the same as this. So now we have balanced the oxidation numbers. So I erased the oxidation numbers, and you're going to have to find some way of keeping track of these things without messing yourself up. Erasing, it can become a mess. So after you do the oxidation numbers, the next thing we need to do is balance the charge. So this side has a charge of negative, I lost my pen. This side has a charge of -4. This side has a charge of 0. So I didn't mention this, but let's assume that this is in an acidic solution. So to balance the charge, what we're going to add is we're going to add hydrogens. And hydrogens are positive. So we can only increase the charge on the side. So we need to increase this product side from -4 to 0. So in order to do that, we're going to add 4 hydrogens. So now this side has a charge of 0. So we balance the charges. I'm going to pause this and erase some things to clean this up. All right, so we balanced oxidation number, we balanced charges. The next thing we need to do is we need to balance the hydrogens. So we have 4 hydrogens on our product side, so we need to get 4 hydrogens on our reactant side. And we're going to do that by adding 2 waters because every water has 4 hydrogens. So we just balanced hydrogen, and if we did this correctly, oxygen should be balanced also. So we have 1 oxygen here, we have 2 oxygens here, so that's 3 oxygens on this side, and then we have 3 oxygens on this side. Not 30, but 3 oxygens. So this half reaction is balanced. All right, now we're going to balance the other half reaction. Let me leave some space for this. To Cl2. So this has an oxidation number of 0. Chlorine over here has an oxidation number of +1. And the other thing is, so chlorine is being reduced. We have 2 chlorines on our product side. We have 1 chlorine on our reactant side. So we need to put a 2 here, so we have 2 chlorines on both sides. So this side has a total oxidation number of +2. This side has an oxidation number of 0. So to go from +2 to 0, when you add electrons, we're going to have to add 2 electrons to our reactant side. And you should be adding electrons to the opposite side of the other half reaction that you balanced. So we balance the chlorines, we balance the oxidation number with electrons. The next thing we need to do is balance the charge. All right, so I cleaned it up a little, and then look, on our product side we have a charge of 0. On our reactant side we have a charge of -2. And so since this is an acid, we're adding hydrogen ions, which are positive, so we need to bring this side up to 0. So we're going to add 2 hydrogens. And that'll change that from -2 to 0. So now the charges are balanced. And let me erase those charges. And this can take a lot of paper, and you just need to make sure that you're not making it so messy that you make a mistake because you can't read your own writing. So the next thing we need to do is we need to balance the hydrogens. So we have 2 hydrogens here from our 2 hydrogen ions, but you also have to be careful. We have 2 hydrogens here, so we have a total of 4 hydrogens on our reactant side, so we need 2 waters on our product side. And that gives us 4 hydrogens, and we have 4 hydrogens on this side, and then we need to check oxygen. So we have 2 oxygens on this side, 2 times 1, we have 2 oxygens on this side. So now this half equation is balanced. All right, so I cleaned it up, and here are 2 half reactions. So this half reaction has 2 electrons on the reactant side. This half reaction has 3 electrons on the product side. So we need both of these to have the same number of electrons, because the electrons need to cancel out in the final equation. So we got 3 electrons, 2 electrons. The smallest common multiple is 6. So we're going to multiply this reaction, the whole thing, by 3. We got to multiply everything by 3 in there. And this reaction, we have to multiply everything by 2. And we're going to add that up. So we're going to end up with 2 nitrogen monoxides plus 4 waters plus 6 hypochlorous plus 6 electrons plus 3 times 2, 6 hydrogens. All right, on our product side, 2 times, we're going to have 2 nitrates plus 2 times 3, 6 electrons plus 8 hydrogens, and I'm running out of room, so I'm going to do this down at the bottom. Plus for this, we have 3 chlorines plus 3 times 2 is 6 waters. All right, so we got this big long equation and it's kind of ugly, but let's look at this. So look, we have 6 electrons on the reactant side, 6 on the product side, so they cancel out. We have 4 waters on this side and 6 waters on this side, so we're going to cancel out, that's going to cancel out these 4 waters, and we're going to be left with 2 waters. We have 6 hydrogens on this side and 8 on this side, so these are going to be canceled out, and we're going to be left with 2 hydrogens on this side. And I think I've canceled everything out, so we're going to rewrite this as a nice pretty equation as much as we can. So we have 2 nitrous oxide, that's its common name, nitrogen monoxide, plus we have 6, this is actually hypochlorous acid molecules. I think I may have called it something wrong before. And so that is, I believe, all of our reactants, and that's going to produce 2 nitrates plus 3 chlorides plus 2 hydrogens plus 2 waters. And then we can take a look at this. Look, we have 6 hydrogens. We have 2 hydrogens here, 4 here, 6 hydrogens, 4 oxygens, plus 2 oxygens here, 6 here. We have 8 oxygens. This has 8 oxygens, 2 nitrogens, 2 nitrogens, 6 chlorine, 6 chlorine. So at this point, it's balanced. Here is our nice, beautiful redox equation, all balanced. Good luck. You just need to keep track of things.